Greetings, ma'am. I'm Pooja M from 4th B section ECE. Today I'm presenting you the first experiment of multisim, that is part B experiments in analog circuits. So I'll be presenting you the RC oscillator first. I'll simulate it and then I'll explain the circuit. So I'll go to analog, op-amp 741 and place it. And I'll flip it vertically for my convenience. I'll take resistors, 3 resistors of value 3.3K. And 2 resistors of value 33K and a variable resistor of 2 mega ohm. And I'll take 3 capacitors of 0.1 microfarad. Let's flip this or rotate this. Now the supply voltages, choose DC power from sources and use it. Now the grounds, let's place it wherever necessary. And one will need it for the oscillator part, so I'll keep it before only. Now I'll make the connections. We'll rename this as Ri, that is input resistance. We'll rename this as RF, that is feedback resistance, and we'll rename this as RComp, that is compensation resistor. Then we'll place an oscillator. Positive terminal of channel A is connected to output voltage, and negative terminal of channel A is connected to the ground. Now we'll save this. I'll run the design. We're not getting any oscillations because the Barkhausens criteria is not satisfied. It will get satisfied only when A beta is equal to 1. So we'll move this. So we're getting sustained oscillations now, which means A beta is equal to 1. So we can measure the output voltage now. Scale is saying that it is 10 volt per division, so per box it is 10 volt. So 10 volt plus 10 volt plus this 0.5 and 0.5 is 1, so 21 volt we are getting. So the output voltage is 21 volt. Now I'll explain the circuit. So this is an RC oscillator circuit. This is the amplifier block which produces 180-degree phase shift, and this is the feedback block which produces 180-degree further phase shift. So feedback block is made up of the ladder circuit, that is capacitor and resistor, 3 capacitors and 3 resistors. So one set produces 60-degree phase shift, and this next set produces 60, and this next set produces again 60-degree. So totally it produces 180-degree. And this 180-degree and the amplifier's 180-degree phase shift totally produces 0-degree phase shift of the 360, which cancels out the negative things, and positive feedback is given to the inverting terminal of the op-amp. So this is an inverting op-amp because the non-inverting terminal is grounded. So this is an inverting op-amp. Then we know the formula. No, we have designed for the oscillator having 200 hertz frequency. So and we have chosen the capacitor of 0.1 microfarad. So 0.1 microfarad and frequency, if we put together in the formula, f naught is equal to 1 by 2 pi root 6 RC, we'll get the value of R, that is 3.35 or 3.56 K, which can be approximated to standard values present in the lab as 3.3 K. So we're taking 3.3 K resistors, and this Ri is 10 times of whatever R we're taking here. So it's 33 K, and gain of this amplifier is A, that is equal to minus RF by Ri. If it's minus RF by Ri, we'll neglect the minus because we only want the resistance of the Ri. So RF is 29 times Ri because 29 is the gain, that is A. So A into Ri is equal to RF. RF becomes something around 957 kilo ohm, as we don't have that value in our lab. So fixed resistors we cannot use for this. We'll use a variable resistor of 2 mega ohm and vary this by this slider. And our compensation resistor is used to nullify the offset, so which is given by the formula Ri parallel Rf. When this is made parallel, we'll get something around 33 K only. So we are placing 33 kilo ohm resistor here. Then we have two supply voltages which are equal and inverted for this and non-inverted for this, and connected to the ground. So that's all is about the RC oscillator. Now I'll simulate the Hartley oscillator and then explain the circuit. So I'll go to analog, op-amp 741. I flip it vertically for convenience and choose two inductors of 0.5 millihenry and one capacitor which is of 0.5 millifarad. And two resistors, actually three resistors. Yeah, one resistor of 1K, other resistor of 100K, and R compensation having 1K. Let's name this as RF, that is feedback resistance. We'll name this as Ri, that is input resistance, and we'll name this as R comp, that is compensation resistor. Now we'll make the connection. We'll place grounds now. Go to power sources. No, we'll place the DC power sources. That is the supply voltage of op amp. Now we'll place the grounds. We'll need another ground for oscillator. So that is all with the connections. Now I'll save it. And run it. Okay, we've stopped it. So the calculation of output voltage is like one division is made up of, one box is made up of 10 divisions. So according to the scale, it's 10 volt per division. So 10 volt here, 10 volt here, and this is considered together as 1 volt because here it's 0.5 and here it's 0.5. So it's 1. So totally it's 21 volt. Output voltage is 21 volt. Now I'll explain the circuit. So this is Hartley oscillator, which is made up of inductors and capacitor. This is the amplifier section and this is the feedback section. It is same like RC oscillator. This produces 180 degree phase shift. This also produces 180 degree phase shift. This is an inverting amplifier as usual, and because the non-inverting terminal is grounded, then two equal supply voltages connected to ground. Then yeah, so we have we've designed for an oscillator having a frequency of 200 hertz. So the formula for frequency is f naught is equal to 1 by 2 pi root L equivalent C, where L equivalent is given by L1 plus L2 plus 2M if mutual inductance is there, but we don't have it now. So it's L1 plus L2. When we put the frequency value, that is 200 hertz, and the fixed capacitor value, that is 0.5 millifarad, into the equation which I told, that is 1 by 2 pi root L equivalent C, we'll get L values as we'll get L value as 1 millihenry. So if it's 1 millihenry, then we'll divide it equally within the two inductors, that is 0.5 millihenry and 0.5 millihenry. So after getting this, then Ri should be chosen as 1 kilo ohm and Rf is 100 kilo ohm. Then R compensation is used to nullify the offset. So that is given by Ri parallel Rf. So when these values are made parallel, the smaller value will usually come. So we've taken it as 1 kilo ohm itself. Then, so yeah, that's all. Thank you.